So, for all the people watching this at home, congratulations. You are on my hit list because we only have 3 people in class and it's pretty lonely, right? There's music out there. So, let's get started with what we're doing today. Today, we're doing multi-step equations. Yay! Multi-step equations. As you know, yesterday we were doing one-step equations. Why were they called one-step? Because all you had to do was one thing to find what x was. As in, move one thing so that the x was by itself. What did we have to move here?
2.
How do we move the 2?
Subtract 2. Yeah. Because you want to get the x by itself.
X equals 3. That's one-step equation, my friends.
There was different styles of multi-step equation too.
Now we have this. This is the beginnings of it. So even this one alone is pretty straightforward.
Yay!
But then we'll get to the fun stuff, don't worry. So this is a multi-step equation right here. So if we go back to the other one, I know we jumped straight to moving the 2. But I did say there was a step number 1 that everyone should keep track of. What's always step number 1? Step number 1 always is to first check that each world, pretty much each side, is as simplified as it could be. Right? So with one-step equations, there's nothing to simplify in each side. That's why we jumped straight to moving the 2. But in multi-step equations, you're going to see a lot of that. If we separate the 2 worlds, is there anything to do on this side over here? No, because guess what? It's just a 25. Is there anything we could do on this side?
Yes.
What could we do here?
Yes. Remove it. Underneath the 25. Can you do one minute?
Okay. So, what could we simplify on this side, if anything? So you're saying subtract the 5.
Yeah.
Is that simplifying?
You're just
You're already moving. That's not what you must do. You have to first check before you move anything what could be simplified.
Yeah.
Why do I keep on doing that? Yes, you guys, you know what to do. You combine these 2, right?
Yes.
For me, it's simpler to subtract 5. It's just my opinion.
For this one,
Yeah.
you're going to see in a little bit why it can't be done in other problems. That's why you must always have in your head step number 1, simplify each side. Make it as simple as it can get. If we were to combine those terms, what does 6x minus 2x become? 4x plus 5 equals 25. Now what do we do?
Subtract 5.
Now we start moving stuff. You know why? Because there is absolutely nothing you could do here on this side. You can't simplify anything else on that world. You can't simplify anything else on this world. Now we must resort to moving stuff. And yes, you want this 5 to be moved over there. Then we get, what's 25 minus 5?
20.
Our new problem looks like this. 4x equals 20. Now ask yourself, what must you do next?
On both sides.
You divide the 4 because we're trying to leave x by itself, right? And we're trying to get this number right there, over there with its other number, its other buddy. So you divide 20 by 4, and x equals, what's 20 divided by 4?
5.
Just like that, you found your x. So, let's do another example. So, let's move on to another example. How about that? So, let's review the steps again, all right? It's an equal sign separating two worlds. Yes, make it a habit of simplifying each side first as much as you can. Is there anything to do on this side?
Yes.
What could we do? Yeah, well, a lot of students here would say, all right, PEMDAS, go into the parentheses, right? That's fine. Is there anything to do inside the parentheses? No. X minus 6 cannot be done. Is there any exponents? No. Is there any multiplication? Yes. You guys remember this from last week. This means multiplication. The negative 4, you multiply it out, aka distributing. What is negative 4 times x? What is negative 4 times negative 6? Positive or negative?
Positive.
That's going to be important because that's the symbol that goes there. Positive 24 equals 2x. Okay, is there anything else you could do on this side?
No.
Is there any? So, okay, side 1 is done. Let's go over to side 2. Is there anything to do on side 2? Because it's just a 2x. You can't do anything, right? Good. So step number 1 is done. Simplify each side as much as you can using all the techniques we've developed to this point. Now comes step number 2. Move all like terms to its designated area. So tell me what needs to be moved here.
24.
Wrong.
4. Negative 4x.
Correct. Hi. So we cannot move this 24 because if we move the 24, it comes over here, and next thing you know, you didn't do anything. The 24 is just still around variables, right? Your goal is to move all like terms to its designated area, right? So we have this 4x here that wants to be over there with its buddy, the 2x. So we've determined that we want to move the negative 4x over there with the 2x because they're like terms, right?
Yep.
So now the big question, the biggest question of your lives, how do I move the negative 4x?
Make it positive 4.
You divide by -4.
Wrong. Correct. So, if you remember yesterday, I said this clearly. Division is used to detach the number from the variable. If you were to divide by -4, the -4 gets thrown over there. But the x is still left behind. Division is only used to detach a variable from a number. But yesterday, if you recall, I did say if you wanted to move the whole term, which is what we're trying to do here, this whole -4, if you want to move that, do it the same way you would a regular number, by using the opposite of its sign to the left. So that's a -4x. Guess what? I add 4x. That cancels out there and it gets thrown over there. So now ask yourself, what is 24 equals, what is 2x plus 4x?
6x.
Now, David, what do you do?
Divide by 6.
Now we want to detach, right? Now we want this number back over there, away from the variable. So now we do our famous division, and we ask ourselves, what's 24 divided by 6? I found my x. 4 equals x. Do you guys see that? So this is a perfect example. If you want to move the whole term, do the same thing you've been doing. The opposite to the sign to the left. It's called the opposite trick. Just do the opposite trick. Division, this is a hint for you guys, is always going to be your last step. It's always going to be used to detach the variable from the number. Cool little trick. Or a cool little hint, I should say. If you just have in your head, okay, I'm going to do no dividing until the end. If you have that in your head, you got it all in the bag. So, this is multi-step equations. How about we do one more, and one more, and one more. Ready? I'm going to do a real, I shouldn't say, yeah, you know what? We're going to go all out. We're going to learn something hard here. All right, my friends. So this is an equation.
I love this one.
This is a long one. But as long as you have the steps in your head, you're golden. And as long as you've practiced all the skills that we have acquired to this point, you're golden. So, please tell me, what's step number 1? Yeah. Think of this as 2 separate sections and make sure each side gets simplified. So how about we do that? Let's start with world 1. This side right there. What could we do here to simplify this? We distribute it out, right? Creating, what's 5 times 2x?
10x.
What's 5 times 6? Positive or negative? So you put the plus 30 sign there because positive 5 times positive 6 is positive 30. Okay, is there anything else you could do?
Nope.
Cool, so move on. What was that? Yeah, so if there's nothing else to do on this side, you move on to the side B. Now we're in Mars. We were in Earth at first, now we're in Mars. So let's simplify this world. How about that? Whew. So what could we do here? Well, simple, just another distribution problem. What's negative 4 times negative 5? What's negative 4 times negative 2x? Positive or negative? Bring down the plus 3x because it hasn't been touched. Is there anything else you could do? Yeah, this one continues on. You could simplify even more. You could combine the 8x and the 3x, right? So what does my new problem look like here? 20. What's 8x plus 3x? Positive 11x. Right? So bring down the other side, and guess what? The reason why I'm bringing down the other side is because, yes, there is nothing else to do on this side. Right? There's nothing to do. So, this, my friends, I'm going to copy this right here. Hold on. You can't. 10x plus 30 equals 20 plus 11x. Remember that. And tell me it. It was 10x.
Plus 30 equals 20x plus 11.
Yeah.
11x? No, 20 plus 11x. Okay, so this is where I'm at, right? I wanted to rewrite this for a reason. Is because this right here is a traditional situation that you're going to come across. And we're about to do it right now, and you're going to see what I mean. What we're about to do is standard in multi-step equations. You're going to come across this a lot of times. You're going to come across this, obviously, but you're going to simplify it down to something like this, and then you're going to start moving. So, but this one's unique because you're going to do two moves simultaneously. What needs to be moved so that all like terms, all species are in its designated area? Well, tell me.
10x. Negative 10x.
Sure. If you really, really look at it, you guys, you're going to be flip-flopping stuff. This 10x, huh?
Would you do that? Either one. You need to like subtract one. Which one?
Haha. So this is what I mean. This is a traditional problem for that specific situation. Doesn't matter where you start. Ow.
It's moving.
Okay. Hopefully that didn't mess anything up. It doesn't matter where you start as long as you move everything to its designated area. So, if you wanted to move the 20, so be it. This 20 wants to be over there with its buddy the 30, right? The other number. It's fine if you do that. But by default, that means you have to move the 10x over there with the 11x. You get that? If you were one of those students that said, hey, I want to move the 30 over there with the 20, guess what? Perfectly fine. But by default, you need to now move the 11x over there with the 10x. You're going to get the same answer no matter what. The goal, remember, doesn't matter where you start, doesn't matter what you move. Well, kind of does matter what you move, but as long as you move all like terms to its designated area, you're going to come out with the same answer. So let's do your example. Let's move the 20. That's what you wanted, right? How do we move the 20? You subtract 20 and you subtract it from its a like term, the 30, right? The other number. So now my problem looks like this. 10x, what's positive 30 minus 20? Plus 10, because positive 10, right? Equals 11x, right? Like I said, by default, that means this 10x needs to be moved over there. So how do you move the 10x?
Negative 10x. Yeah.
This, my friends, is a traditional multi-step equation problem. So what's 11x minus 10x? 1x, aka x. So now you don't have to do anything. You found your answer right away. Obviously, if there was any other number, such as a 2, you just divide by 2 and then divide, and then you have your x, right? But in this specific case, we were lucky. We found x. X is 10 right off the bat. Right? Oh, but wait. You weren't one of the students that wanted to move the 20? You weren't one of those students? That's fine. What, you were one of the students that wanted to move the 11x first? That's perfectly fine. You minus 11x, cancels out, it gets thrown over there. What's 10x minus 11x? Negative 1x. Make sure to bring everything down step by step. What do you do now?
Do the negative 30 on the inside.
Negative 1x equals, or aka negative x, just fine, right? What's 20 minus 30? Negative 10. You're never ever finished if your variable is a negative. So if you left this as negative x or negative 1x, it doesn't matter. It needs to be positive. So what do? If we remember, you divide by -1, blah, 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 blah. Or you did what I said, which was get that negative and chuck it to the other side, right? Just chuck it and then throw it over there, which flips the sign of the -10 into a positive sign. And just like that, 1x, or as your answer is going to be seen, x equals 10. Doesn't matter where you start. As long as you decide to move stuff accordingly and correctly, you will get the correct answer. As long as you do that. Does that make sense?
Yes.
I don't know. It's just, I don't know.
Let's have fun with that.
I really do not know. Okay.
Ow.
Literally, that was multi-step equations. I personally think the hardest part to multi-step equations for students is the simplification part. Is simplifying correctly just by doing one mistake, literally one mistake. If over here you decided to distribute out the 5 times 2x and then the 5 times 6, and you were by, I don't know, somehow putting a -30 instead of a +30, just because of that negative, your whole answer would have come out wrong. Why? Because you bring down, again, the -30 underneath here. And next thing you know, when you do start flip-flopping, you get wrong answers. That's why it's important to have your simplifying part done correctly, precisely. Because the last thing you want is your simplification to make you get the wrong answer.
Are we going to do more of those tomorrow or today?
Today, you guys are going to do a whole bunch of problems regarding multi-step equations. And in the quiz, a lot of more problems.
Yeah, I love these.
So are we ready to start?
Yes.
Let's do this. Oopsies.